Following on from some of the earlier videos, we were trying to show that this series will converge for p being greater than 1. And the way we did that was by integrating this. Well, integrating this, in some of the earlier videos, integrating this would then take us to here, would then take us to here, and then when we got to this stage here, we realized that for p being greater than 1, this whole thing here will tend towards -1, and -1 times this thing will give you a finite answer. This thing here will be finite, therefore this thing converge, therefore the series will converge. So now we need to consider the case where p is less than 1. So for p being less than 1, we would follow the same process. So integrate this, and then that will then take you to here. That will then take you to here. So when you get to this stage here, for the case of p being greater than 1, we realize that this thing here tends towards -1. But now we need to consider p being less than 1. But before we do that, let's just tidy this thing up. So let's rewrite this as this. So now if you look at this, negative times a positive 1, that will give you -1, and then a negative times a negative p, that will give you a positive p. So let's just rewrite this as this. So now now you've got minus this thing here. So you can visualize this thing here as 1 over, well, this thing here you can visualize as 1 over b to the power of 1 minus b. Well, tidy this thing up, it will then give you this. So tidying up, that will then take you to here. So now if you look at this for p being less than 1, for p being less than 1 minus p, meaning this thing here will always be positive, this thing here will always be positive. But for example, let's just say p is 0.7. So 0.7, so here you've got 1 take away 0.7, which will give, then this whole thing here will be 0.3, which is bigger than 0. So this thing here will always be positive. This thing here will always be positive. But then don't forget, if you look at this, p could be less. Well, p must be less than 1, but p could be, let's say, 0.999999, say. P has a right to be this. So if you get 1 take away this, you're going to get something like this, 0.0 blah 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 whatever around here. So this thing here is going to be a positive number, and then this thing here, it has a potential to be a very, very small number like this one here. So suppose this thing here is a really small number, let's say 0.0000001, say. You see, how would you could make an argument that well, if you have this, where that p to the power of 0.00000, a really small number, and then take the limit as b heads towards infinity. Well, here you might be unsure whether or not this will converge or if this will diverge. Here you've got something very, very small, and then b gets larger and larger. So how do you know which way it will it diverge? Will it get bigger and bigger and bigger, or will it head towards 0, or what? Well, b to the power of a very, very small number. To answer this question, put something very, very big into the b. So put hang on. So you've got b here to the power. So this is b here, and then to the powers of something that could be very, very small. It could be very small. Let's take a small number like this, and then take the limit as b. Remember, b is this whole thing here. Take the limit as b tends to be very, very big. So now put something very, very big into the b. So put 10 to the power of 1,000,000,000,000, much larger than this. So make it really, really big. So you put a very, very large number into here. So here you've got 10 to the power of whatever, and then to the power of whatever again. So if you have x to the power of a to the power of b, that will be x to the power of a times p. So you would get this times this. So you would get this times this. So that would give you roughly 10 to the power of 1, 1, 1, 1, 1. Maybe not as long as this, because you've got to get these two and multiply them together. So it would give you this thing here. Well, this thing here, you can see it's already a very, very big number. So the point here is that as b heads towards infinity, this thing here is just going to get very, very big. It will be a big number. If you put this thing here will diverge basically. So now this thing here diverged. Take away 1. This is irrelevant because this is going to be very, very big. So the whole thing here will diverge, meaning it will just get bigger and bigger and bigger. And then you times something that stays constant. So therefore the whole thing will just get bigger and bigger and bigger, meaning it will diverge. So going back to here, for p being less than 1, this whole thing here will diverge. Therefore this series will diverge. So we've taken care of the case where p is greater than 1. We've taken care of the case where p is less than 1. Now we need to consider the case where p equals 1. Now for p equals 1, this will be, well, you put the 1 into the p here, so this will give you this series here. And we've done this. For this series, we managed to track this. We managed to track the partial series in between this and this. So now take n. Remember, capital N, for example, let's say S4, the first 4 terms, let's say. So you put a 4 into here, and then you put, so it would be natural log of 4, and then here it would be natural log of 4 plus 1. So for the first 4 terms, it would be this. But then here, allow capital N to head towards infinity. Well, as capital N heads towards infinity, this thing here will just get bigger and bigger and bigger and bigger. Therefore, this is going towards infinity. This is going to diverge. So therefore, this must also diverge. So for the case of, well, we've done this before. So if you don't understand this part, track back to one of the earlier videos. But for the case of p being equal to 1, the whole series will diverge, because this thing here will just get larger and larger and larger. Okay.